Hi everyone and welcome back to Metallurgy with Marina. Today we're going to be talking about crystal structures. So right here I have a simple cubic structure. So there are 8 atoms that make up this model. 1, 2, 3, 4, 5, 6, 7, 8. If you were to take a cube section of this atomic model, you would have 1/8 of each of these atoms inside that unit cell. So 1/8 times 8 atoms would be 1 atom per unit cell. Now it has a pretty low packing efficiency. And so there aren't very many atoms in that unit cell. Because of this, it causes it to be a bit unstable. An example of a metal that has this simple cubic structure is polonium. So polonium is commonly used as an energy source and also as a static eliminator. As I said, it's fairly unstable due to its low packing efficiency, but that is our simple cubic structure. Let's move on to body-centered cubic structures. This is an example of a BCC crystal structure. So as you can see, it's very similar to the simple cubic structures as we have the 4 atoms on the top and 4 atoms on the bottom. However, with the BCC crystal structure, we have 1 in the center as well. BCC stands for body-centered cubic. In this model, we have 9 atoms in total. So we have 1, 2, 3, 4, 5, 6, 7, 8, and then 1 in the middle makes 9. So if we were to take a cube section of this model, we would have 1/8 of each of these top and bottom atoms, making 1/8 times 8 atoms is 1 atom, plus that atom in the center, making 2 atoms per unit cell. A couple examples of metals with a BCC crystal structure are tungsten, which is commonly used in heavy metal alloys, and molybdenum, which is commonly used in steel. Next, we're going to talk about face-centered cubic structures. This is an example of an FCC crystal structure. FCC stands for face-centered cubic. So this model is actually made up of 14 atoms. We have an atom in each face of the cube. So we have 5 on top, 4 in the center, and then 5 on the bottom. If we were to take a cube section of this model, we would have 1/8 of each of these atoms on the corners, making up our corners, and then we would have half of each of the middle atoms. So there are 6 middle atoms in total because the cube has 6 faces. So that's 3 atoms plus the additional atom from the corners. So 1/8 times 8 atoms is 1 atom. So 4 atoms per unit cell. This type of structure is very common in a lot of our metals. We use it in aluminum, nickel, copper, gold, and even silver. So this is an FCC crystal structure. Now let's learn about HCP crystal structures. This is an example of an HCP crystal structure. HCP stands for hexagonal close packed. On the top we have 7 atoms, in the middle we have 3 atoms, and on the bottom we also have those 7 atoms. If we were to take a unit cell of this crystal structure, we would have these 6 atoms on the top, surrounding the atom in the middle, and 6 atoms on the bottom, making a total of 12 atoms, contributing by 1/6, so 12 times 1/6 is 2, plus the 3 atoms in the middle makes 5, and then the top and bottom atoms contribute by 1/2, because 1/2 of them are in the unit cell, making it a total of 6 atoms per unit cell. A couple examples of metals that have an HCP crystal structure are titanium and magnesium. Thanks so much for watching my YouTube video today. If you could please like and subscribe to this channel, I would really appreciate it. Also, if you are interested in pursuing a degree in metallurgical engineering, make sure to check out our website. It's msc.utah.edu. And again, my name's Marina, and I work up at the University of Utah. I hope you have a great day, and I'll see you next time.